Welcome back. Welcome to the review of the area under a curve, Riemann sums, and the definite integrals. Now, this covers 5.2 and 5.3. So by the end of today's review, if you do not already know how to do so, you should be able to approximate the area of a plane region, find the area of a plane region using limits, evaluate the definite integral using limits, and evaluate definite integrals using properties of, you got it, definite integrals. So, 4 different types of problems. You should be able to master each one. All right, we're going to do a little maximum minimum from 5.2 and a little Riemann sums and definite integrals from 5.3. Now, in both cases, you're going to have to use these summation formulas. But here's how it works. The top sets you're going to have to use to find your maximum minimum, your area under a curve using rectangles. The bottom ones you use when you use Riemann sums and definite integrals. Now, what this works is how this works, in case you forgot how to use it. The first one is if you find the sum of a constant. Now the I equals 1 is your lower limit. The n is your upper limit. That's how many pretty much rectangles you have when you're dealing with the n's here. Now, in this case, and all the i's are going to be 1. C times n is whatever the constant is times the number of rectangles times n. Second one, say you have a variable. So pretty much like x raised to the 1 power. Or in this case, I raised to the first power. So, number of rectangles plus 1 divided by 2. N plus 1 divided by 2. If I'm using the expanded form for the Riemann sum, or the definite integrals, distribute that in there, n squared plus n over 2. Same exact formula, one's just expanded, one's not. Right here, I squared, n plus 1, 2n plus 1 divided by 6. All right, if I distribute this in here, take that and multiply it in there, you get 2n cubed plus 3n squared plus n all divided by 6. How we doing? All right. Right here, if you have a cubed n squared times the quantity n plus 1 squared all divided by 4, or if I FOIL this and multiply that in, distribute it in, you get n to the 4th plus 2n cubed plus n squared all divided by 4. Now, there is things like I to the 4th, I to the 5th, and so on. We're just going up to I to the 3rd in this class, in these lessons, okay? Now, first set of problems is minimum area, maximum area. Maximum is easier to find, but when you find the minimum area, what you want to do is you want to find the area of the total area of all the rectangles under a curve that's inscribed. Inscribed is going to be less than the actual region. So all this little shaded parts here, you're going to miss out on. So you'll have an estimate of the answer, but you won't have the exact answer. Now the way to do that is, first you have to find mi, that's what you're going to plug in to the actual function, and you're going to multiply that by delta x. Now delta x is the width of each one of these rectangles, which is just b minus a over the number of rectangles, okay? They all have the same width in these cases. Now, what you're doing is pretty much finding the length times width of each rectangle, and the f of mi is going to give you all the heights of each rectangle, and the delta x is all the widths, which is all the same. Now, mi is actually whatever delta x is. mi's are all these heights, so it's delta x times, right? Ready for this? I minus 1, because you're doing all the left-sided parts of each rectangle. Now, when you do maximum area, that's the area of the circumscribed rectangle, it's greater than the actual region. What you're going to use is capital M subscript I equals delta x times I. So that's the width, all right, times i's are all the right sides of each rectangle. And that gives you an area. See, you can see that rectangles kind of overlap your actual picture. It's going to be a little bit larger than your actual area. So if you did want to find the best answer, your best method would be probably to find each one of these and take the average between the two. That would give you a more realistic answer than just one or the other. Okay, so these answers are a little smaller. These answers are all a little bigger. But we're going to do each one. And we're going to do it for the same problem. So let's start with problem number 1. Everyone ready? Good. Find the area of the region bounded by the graph f of x equals x squared plus x. And we're going to do min for minimum. And the x-axis from 0 to 2, lower limit, upper limit, with 6 rectangles using lower limit sums. So, ready to go? Delta x, as I said before, b minus a over n, which is 2 minus 0 over 6. So 2 over 6 is 1/3. So that means that each one of the 6 rectangles has a width of 1/3 because 6 times 1/3 is 2. That's how you get the whole distance is 2. Lowercase m subscript I equals delta x, the width, which is 1/3, times I minus 1 over 3. All right? Easy so far, right? Now what we're going to do is we're going to use the formula S of n, little s, because it's the minimum's little, maximum's big, right? Maximum's lowercase. No, uppercase. I'm saying uppercase, but saying lowercase. All right, so f of mi means you take this and you're going to put it in for each x. And then you're going to take your delta x, which is 1/3, and then you're going to multiply the whole problem by 1/3. So I minus 1 squared plus I minus 1, in both cases over 3, times 1/3. Now here's a tricky part. I actually had to do this whole video over because I messed this up originally. When you square this first part, I minus 1 squared, as you FOIL it, I squared minus 2i plus 1, but you also have to square the 3. I forgot to do that. So it's all that over 9 plus I minus 1 over 3 times 1/3. So this whole thing is times 1/3. Now because this whole thing is times 1/3, using the constant rule, I could take the 1/3 and just put it in front of the summation. And then when I want to combine these terms, though, what I want to do is I need the denominators to be the same. So I have to multiply this piece right here to get it to be 9. You have to multiply the denominator by 3. So to keep it the same, you have to multiply the numerator by 3 as well. So 3 times I is 3i, minus 3 times 1 is 3 over 9. These two things are equal. I just need them both to be 9. So now I could take my 1/3. I left it out. I'm going to drag my 1/3 forward here. I squared stays. Negative 2i plus I plus 3i is I. 1 plus negative 3 is 1 minus 3 is negative 2. And that's all over 9. See the 1/3? I just moved to the front. Now to make this easier, I could take this 9. I can move that out to the front too. So 1/3 times 1/9 is 1 over 27. 9 times 3 is 27. So I'm left with an I squared, an I, and a minus 2. And I could summate or take the sums of each one of these. And each one, 6 rectangles, is from 1 to 6. Got it so far? I'm going to use my formulas, my summation formulas. All right, the sum, I squared, equals n plus 1, 2n plus 1, all over 6. My n is 6, so I put 6. 6 plus 1 is 7. 2 times 6 is 12, plus 1 is 13, divided by 6. My summations for I are n, which is 6. All right, so 6 times 7 divided by 2. And then constant is 2 times 6. See it. 6 times 7 times 13 divided by 6, I think, is 91. 6 times 7, 42 divided by 2 is 21. And 2 times 6 is 12. So 91 plus 21 minus 12 is, what's that, 112 minus 12 is 100. So 1 over 27 times 100 is 100 over 27, or 3.703, I think it was, 3.70. All right, that's it. That's all there is to do it. The hardest part is just remember when you square it, numerator and denominator, you square it. All right? Now, that's the minimum. What we're going to focus on now is the maximum. So area of the region bounded by the graph, same exact formula, same exact delta x here. So your delta x is the same, 1/3. Now, delta x times maximum is I, not I minus 1. So it's just 1/3 times I, or I over 3. All right, next step. This formula, same exact formula, you just plug this in instead of f of lowercase mi. So this I over 3 goes into this third, goes into there. So I over 3 squared minus I over 3 times 1/3, right? I squared over 9 plus I over 3 times I over 3. Oh, sorry, this should be a plus. It just says minus, but it's really a plus. All right, so I squared over 9 plus I over 3. Just drag the 1/3 forward. Now, you don't have to get the same denominator here because you have two different sums anyway. So all you have to do here is 1/3 times 1 over 9, the sum of I squared, plus 1 over 3, the sum of I. All right? Using our summation formulas, your I squareds are n plus 1, 2n plus 1 over 6. So 6 times 7 times 13 divided by 6, and you're going to multiply that answer by 1/9. 1/3 times I is 6 times 7 divided by 2. All right, so there's a nice form. Multiply all this stuff together. You get 1/3 times the quantity 1/9 times 91 plus 1/3 times 21. A ninth of this is like 10 and 10.11 plus 7. 1/3 of that. 1/3 of 17-ish is 5.7. All right, so that is your maximum. So you notice the two answers were kind of similar. Your first answer was 3.7. This is 5.7. So your actual answer will come on probably around 4.7 if you did it a way not involving maximum and minimum. All right, so that's not too terrible, is it? No? Awesome. So now we're going to move on to the next one. So those are the first two concepts for 5.2, and this is 5.2. This is a definite integration using summation. Now the way these work is also fairly simple. First step is to find delta xi. Delta xi is found the same way we found delta x before. It is b minus a over n. Now in this case, though, we don't know the number of rectangles. Actually, we do. The number of rectangles is infinite. This will give us an exact answer because n is going to be infinity, and we're just going to pretty much solve through everything and then reduce in the end. You end up with 2 over n. Now, ci, this piece right here, which is very important, that is going to be a. Okay, a is going to be your lower limit sum plus I delta x. Okay, that's because each rectangle can have different varying sizes. -1 plus I 2 over n. -1 plus I 2 over n. -1 plus 2i over n. That's it. That's your CI. You're going to take this. You're going to plug it in for each, for the only x. You're going to take this, and you're going to put it there. So -1, 2i over n, quantity squared, plus 4, don't forget your plus 4, times 2 over n. Back to algebra. Everything is algebra. Algebra is important. FOIL. -1 plus 2i over n times -1 plus 2i over n. So that's 1 plus, let's see, 1 minus 2i over n minus 2i over n. Oops, there you go. You expand it. Plus 4. So this is going to be 1 minus 2i over n minus 2i over n plus 4i squared over n squared. Plus 4. 1 plus 4 is 5. So it's 5 minus that plus that times 2 over n. Here's the key. See this 2 over n? You're going to distribute it in there. So you get 10 over n. 5 times 2 is 10 divided by n minus 8i over n squared plus 8i squared over n cubed. All right? You're going to use your summation formulas. So you're going to pull out, let's see, a 1 over n. You're going to pull out an 8 over n squared. You're going to pull out 8 over n cubed because you want your constant, I squared, I cubed if you have one. And now we use our formulas. Constant is c times n, so 10n. N squared plus n over 2. You just actually plug these straight in the expanded forms, go directly in here. So there's no things to plug in for n because we're going to do n in the end. That's infinity. We're going to have to use L'Hopital's rule from integration. Yes. So we plugged everything in here. The only really thing here is the 10n. So 10n divided by n. 8 times n squared, 8 times n. N squared times 2 is 2n squared. Distribute the 8 to everything on top. N cubed to the bottom. Still following me? Good. Now what you're going to do is reduce. 10n over n is 10, right? Minus 8n squared divided by 2n squared is 4. 8n divided by 2n squared is 4 over n. See? Everything in the fraction bar from top divides by the denominator. These two reduce to 8/3 because the n cubes cancel out. This reduces to 4 over n on bottom. This reduces to 4 over 3n squared on bottom. Now the important part, the most important part here is since n is approaching infinity, the rule is anytime you have infinity or negative infinity as a denominator and a number as a numerator, your answer is 0 because anything divided by infinity or negative infinity equals 0. So anything here becomes zeros. So you're left with 10 minus 4, 0, plus 8 thirds, 0, 0. 10 minus 4 plus 8 thirds is 8 and 2 thirds. 26 over 3, 8.67, all excellent answers. All right, ready for the last concept? Yes. All right, use the Riemann sum to find the definite integral of the function. So, right here, delta x. What is indeed delta x here? So, same concept, b minus a over n. So it's 0 minus negative 3 over n, which is 3 over n. Okay, this is pretty much the same thing we just did again. Just different names for everything. Ci, remember Ci equals a plus I delta x. We just did this. So a is negative 3 plus I times 3 over n, negative 3 plus 3i over n. We're going to take our Ci and what do? We plug it in for x. We take our 3n, we throw it in the end. Now, so this becomes 2 times negative 3 plus 3i over n, quantity squared plus 5 times 3 over n. Good. You exponents first. That thing's going to get multiplied by itself, so negative 3 plus 3i over n times negative 3 plus 3 over n. This becomes 9. Then you get minus 9i over n minus 9i over n. There's 2 of them. You square this, 3i squared over n squared, plus 5 times 3 over n. Now, you're going to have to distribute the 2 into here. 18, 36, 18, plus 5. 18 plus 5 is 23, right? And then final last step, multiply all 3 of these by 3, and put an n on the bottom. So you get 69 over n, 108i over n squared, and 54i over n cubed. Awesome. Pull out 1 over n, 108 over n squared, 54 over n cubed, giving you your summation stuff. Go back to your expanded form, summation formulas. So Cn is 69n, I is that, and I squared is that. This goes directly in here, and this is the only one where you have to do a little work. All right, this over n, distribute the 108, distribute the n squared, distribute the 54, distribute the n cubed. Do you have to distribute it to things you know are going to turn into 0? No, you can take shortcuts around there, but I'm just showing you every step of every one. 69. 108 n squared divided by 2n squared is minus 54. Minus 54 over n, because there's more n's on bottom. That reduces to 18. The n cubes cancel out. More n's on bottom, more n's on bottom. 69 minus 54 minus 0 plus 18 plus 0 plus 0. 33. And this is much more accurate than the actual maximum minimum Riemann summation formulas with the rectangles. Because you have an infinite number of rectangles. Right? We good? Alright. Now we're going to do 4 more problems, just like the 4 problems we just did. And hopefully you got it again. So first off, minimum. Just like number 1. Delta x b minus a over 1. 4 minus 0 over 8 is 1/2. Delta x I minus 1. So 1/2 times I minus 1 is I minus 1 over 2. You feeling it? You feeling a little better? Use our formula. S of n from 1 to n, fmi delta x. Take I minus 1, you're going to plug it in. Plug it in. So I minus 1 squared minus 3 times I minus 1 plus 7 times 1/2. Now, you have to expand this. I squared minus 2i plus 1 over 4 minus 3i plus 3. Oh, I didn't expand it. Over 2 plus 7 times 1/2. All right. You need both these to be 4, so you have to multiply this by 2 over 2. This stays the same. 6i minus 6 over 4. Still 3 plus 7. If you want to put this over 4 now, you can. I squared is the same. Negative 2i minus 6i is minus 8i. 1 minus 6 is minus 5, all over 4. And now I'm just going to make this 7. I want to bring the 7 in, so 7 times 4 over 4 is 28 over 4. And I can do negative 5 plus 28 is 23 over 4. All right, so to add this to this, I had to get 7 over 4. I had to get the same denominator. I also took this 1/2 before and moved it in front of the summation. So it's 1/2 summation, I squared over 4 minus 8i over 4 plus 23 over 4. If you want, take all the 4s. So to take a 1/4 out, 1/2 times 1/4 is 1/8. Left with I squared minus 8 summation of I plus summation of 23. Now, when you use your summation formulas right here, you are going to not expand it because you're actually plugging your ends in. You're going to plug in 8s into each one of these. 8 plus 9 plus 2 times 8 plus 1 over 6. 8 times 8 plus 1 over 2. And then just 8 times 23. All right. Multiply this out, divide by 6, multiply this out, multiply that out. You get 204 minus 288 plus 184. 1/8 of all that, 12.5. All right. Got it. Don't forget the 1/8. You pull it out, you got to put it back in. All right, we're going to take the same formula down. Now we're going to do maximum. Delta x is the same. 4 minus 0 divided by 8 is 4 over 8, or 1/2. Delta x times I is 1/2 times I, or I over 2. All right. Use our formula. I over 2 gets plugged in here. I over 2 squared minus 3 times I over 2 plus 7 times 1/2, which is our delta x. I squared over 4 minus 3i over 2 plus 7 times 1/2. Yeah, you got it all right now. I see, you got the hang of this. This becomes 3i over 2. I squared over 4 minus 3 over 2 plus 7 times 1/2. Now, you do not have to get same denominators down here because there's nothing to combine. There's no like terms to combine. I could treat each one of these as a different summation now. So I'm just going to drag the 1/2 forward. If you want to distribute it, then you can. It's up to you. I'm going to take the 1/4 just out of the I squared summation. I'm going to take the negative 3/2 just out of the I summation. And then I just got my 7 all over here. Use my formulas. 8, 9, 17 times 1/4. Negative 3/2 times 8, 9, 2. And then 7 times 8. Notice everything's similar. The only difference is there's different coefficients in front. 1/2 of 51 minus 54 plus 56. Half of 53 gives you 26.5. Notice this was 26.5, the other one was 12.5. So there was kind of a large difference between the two. But that happens sometimes. It's allowed. All right. Any questions? Questions? Email me. Got it? All right. So me too. Yeah. Am I your way? No. All right. Let's move to the next problem. All right. Next problem. Problem number 7. You got it? Oh, I jumped ahead too far. 2 minus 1 over n. 1 over n. 2 minus 1 over n. A, I plus delta x. So A is my 1. I, delta x is 1 over n. So it's just 1 plus I over n. Plugging in this equation, 1 plus I over n, you're going to have to cube it. So 1 plus I over n cubed minus 4 times 1 over n. Now when you cube it, it's 1 times I over n and 1 times I over n. So if I just square this, if I FOIL it, I get this, and then I have to multiply it again. So this is 1 plus I over n squared, and then to cube it, I have to multiply one more time. So then I FOIL it in, FOIL it in, FOIL it in, all right? And then this expands to 1 plus 3i over n plus 3i squared over n squared plus I cubed over n cubed minus your 4 times 1 over n. 1 minus 4 is a negative 3. All stays times 1 over n. Take the 1 over the n. The top stay the same. Add 1 exponent to the bottom. N squared, n cubed, n fourth. All right. Now, I'm going to have 4 pieces here for summations. All right. So, summation number 1. Take 1 over n out, negative 3. Take the 3n squared out, I. 3n cubed out, I squared. 1 over n to the 4th, I cubed. We good? Now, you can use our summation formulas. Whoa, we got 4 of them. Negative 3 times n. N squared plus n. Just substitute this stuff right in here. Throw it in. I wish I had smart TV, which is regular TV. All right. Distribute this stuff back in. Negative 3n over n. The 3's, n squared on bottom. 6, 9, 3, n cubed. Top stays the same, 4 into the 4th. Now, you could divide all this through. Usually what I just do is look for the numbers that are matching, and then I just write them down, but I'll write them all down for you. Negative 3n over n is negative 3. This just becomes a 3/2. This is eventually going to become 0 anyway because more n's on bottom. 1, 3/2, n on bottom, n squared on bottom. They're going to become zeros. N to the 4th over 4 n to the 4th is 1/4. Going to become a 0, going to become a 0. Negative 3, 3/2 plus 1 plus 1/4. Boom! Answer is negative 1/4. All that for a negative quarter. But at least you got a very accurate, very good answer. Now the reason this is negative 1/4 is because part of, see this negative? The beginning of the graph is going to be, it's going to have some pieces that are under the x-axis and some pieces that are over, and a lot of it just cancels out. That's why you're left a little bit more on the bottom. That. All right? All right? So, and you remember x cubed looks like this, the S-curve. And it starts down 4, so that's why it's a little lower. That's why there's more stuff underneath. Ready? Last question of the review. Number 8. Use Riemann sums to find the definite integration of the function. So, good, you're done. Delta x, b minus a over n is 2 over n. Ci is a plus I delta x, a which is 1, plus I 2 over n. 1 plus 2i over n. You're going to take this and you're going to plug it in for x squared 2 times 1 plus 2i over n squared plus 3 times delta x, which is 2 over n. FOIL this. 1, 4i over n, 4i squared over n squared plus 3 times 2 over n. Distribute the 2 in here. 2, 8, 8. 2 plus 3 is 5 plus 8i over n plus 8i squared over n squared times this. Distribute the 2. 10, 16, 16. N squared, n third. All right? Constant I squared. Pull out 1 over n, 16 over n squared, 16 over n cubed. Direct substitution of our expanded summation formulas. 10 times n, 16 over n squared times that, 16 over n cubed times this. All right? Oh, I didn't expand that one. Oh, I didn't put my expanded forms down. Well, this should be the expanded forms. Put the wrong things here. I'm going to fix that. All right, anyway. You have the formula from the last sheet. 10n over n. 16, 16. 2n squared. 32. 48. 16 over 6n cubed. Oh, went too quick. All right. 10n over n is 10. 8. 0. 32 over 6, we just did 6 over 3, same. This is going to be 0, this is going to be 0. 10, 8, 0, 16 over 3, 0, 0. Add them together, and you get 23.3, 23 and a third. 670 over 3, I think. That's your answer. All right, so that right there is the review for 5.2, 5.3. Hopefully you learned a little bit. Hopefully you guys understand it. Hopefully you're going to be good at this stuff. All right, because remember, being good at math is excellent.